Okay, so our first actual quiz, kind of moving ahead here, not the mini stuff anymore. You will notice there's some overlap from our first one. In that, we're going to be starting with equations, especially the fractions and things like that, just to make sure that we've got a grip on this. So just like with any of them so far, and if any of you are speed demons and end up ahead of where we're at, and you want to be able to check things as you're going along, and you're here in class, of course, I do have a key up here in front if you want to be able to check and see what's going on. So I get my distributing done. So I look and I go, okay, my first job is to look for like terms. Now again, like terms means not only they're alike, but they're on the same side of the equals. They're on the same side of my kind of equals wall here. Because if they are, I don't do opposites to put them together. I just go ahead and combine them as they are. So if I owe somebody $8 and I pay them back $4, now I owe them $4. If I have $14 and I go spend $10, I have $4 left. So once we distribute, we combine like terms. Now it just becomes getting all my variable terms to one side. Now again, I like to keep mine positive. So I'm going to move the negative x. You could move the 6x if you wanted to. And I just sort of work my way along here, making sure things are going all right. Okay, all my x's are on one side now. That's good. I need to work on getting those isolated. So I minus my 4 to the other side. And as I continue to keep saying, don't be worried if you get to the end and you're like, oh, I'm getting a fraction, something must be going wrong. No, not necessarily. If we're doing an application problem, maybe, but otherwise we should be in pretty good shape. Okay, have some confidence that you know what's up. But again, that last step, make sure you're dividing by whatever's with the x, because that's one issue I saw in the last quiz. Some of you like it here and you divide by -8. We don't want that to happen to you. So you're like, okay, distribute all the way through. It's one of the reasons I like using arrows. Make sure I do it to all terms. Negative times negative is positive. We're testing out your attention to detail here. So again, no like terms this time on the same side of the equals. So I'm going to go ahead, I'm going to get my x's together. Moving them over here would give me my positive x's. You don't have to do it that way though. Again, once we get those x's all to one side, then we can work on isolating them. So I can plus my 35 over. Let's see, negative 12 plus 35 is 23. And divide by 2. And again, if you're more of a visual learner and you want to put the plus 35 plus 35, or the divide 2 to keep things straight, by all means do it. Okay, you've got to find what's comfortable for you. So we work through those, we get those set. And again, those will be multiple point questions on the quiz because there's several steps to them. So it's always good to show your work so I can get you credit for as much as we can. Okay, proportions. I'm always going to make sure I get the parentheses working. Just so when I get to this point, I can get those guys in there. And again, the key is going to be, now it looks like number 2. I've got to make sure I distribute all the way through and don't just do it to the first term that I see. And now I can actually use number 2 kind of as an example here. Get all the x's together. Need to get my x's alone. So I want to get that plus 24 out of there with its opposite to minus it or subtract it. And if you're good on that work, but you're maybe not good on the details, you know you're minusing 24, but somehow you end up adding it instead, you know, use the calculator if you need to, and then we'll divide both sides by 2. So nothing that works out too terribly bad. Thank you. So then come a couple of our favorites. You're like, ugh, fractions again. All right, so we get rid of the fractions by multiplying through by an LCD. So the question becomes, what's the LCD on this one? 21. Because if I started counting by 3s and 7s, 21 is going to be the first number. If that's something you're still struggling with, there's a way out. You just multiply the numbers that are different. I don't have to do the second 7 here. Together, it may not be the least, but it'll still work. But in this case, okay, so we got the 21. This is the part that gets a little interesting. Because remember, as we go, we multiply by whatever's up in the numerator, and then divide by what's down here. So 21 times 2 is 42, but there's an r, so 42r divided by 7 is 6r. Bless you. 21 times negative 3, and again, if you need to go to the calculator, that's okay, is negative 63 divided by 7 is negative 9. So far, so good. Everything's coming out, no fractions. 21 times 3 is 63, divided by 7 is positive 9. And 21 times negative 1r would be negative 21r, divided by 3 is negative 7r. So multiply times whatever's on top, and then divide by what's on the bottom of that fraction. So I'm like, okay, got rid of the fractions. We'll get to see that again in 5. Ooh, I got like terms this time. Ooh, wait a minute though. Negative 9 and positive 9, they cancel. Now, before you get here and go, ooh, it's no solution, work it through. Okay, let's get all of our variable terms to one side. You're like, hang on here a minute, Harty. So what's left over here? Okay, it doesn't mean the equation's gone, it just means they're opposites. There's 0 over there. And I can finish a problem like this off. Oops, I don't want to divide by r though, because then my variable's going to disappear. That was kind of silly. And I get to where r is 0. Again, patience through these. We're not on a time limit. Okay, we don't have to go in a hurry. Just got to make sure we're doing things correctly on those. Again, on 5, we can take on the same format that we took on 4. If you're not sure what the LCD is going to be, okay, there's 2 4s. I don't need them twice. I can multiply those guys together. Now I'd get 24. Now some of you are good with your LCDs know the LCD here would be 12. But again, if you did it by 24, it would also work. Your numbers are just going to be bigger until the very end. So, but we'll do it using the LCD, again, which would be 12 in this case. And again, it just works. 12 times 3 is 36. Divided by 4 is 9. Don't lose your x that's there. 12 times 5 is 60. Divided by 2 is 30. 12 times 2 is 24. Divided by 3 is 8. Don't lose my x. And 12 times negative 5, gotta watch my sign, it's negative 60, divided by 4 is negative 15. And again, if I've done it right, the fractions disappear. If something went wrong and I still have a fraction, I need to go back and look at my LCD because something didn't work. And I can only use one LCD for the whole problem. So it's not like, well, I'll use 8 over here because it's 4 times 2, and I'll use 12 over here because it's 3 times 4. Won't work. So once we get here, get all my x's to one side. That turned out nice because I'm just down to 1x and minus the 30 on over. And again, that's equation stuff. That's the basis of this class, is being able to take care of equations, even with fractions or some weird thing like that. So that's why we keep taking a peek at that over and over and over here. Then became our arch nemesis. Spit that out. Let's try that again. Our arch nemesis, there it is, for the first mini quiz we did. Solving for a variable. Ooh. Whenever we're solving for a variable, I first look and I say, okay, what am I solving for? I'm solving for L. Well, there's only one term here with L, thank goodness. So my job becomes get that boxed part alone. Okay, I'm adding, or I'm plussing 2W to it. So we'll minus that from both sides first. And again, I look at this and I'm like, oh, this isn't bad now. If I want to get L alone, I'm multiplying it by 2. I've got to keep thinking about opposites. And I get to having my variable by itself. Okay, that wasn't too bad. But again, you've got to just jump in with these. It can be intimidating if you start looking at it and you're like, oh, there's like 3 variables here. Just remember your rules, box in what you're trying to find, and go from there. So I look at the next one. I'm like, okay, I'm trying to get C. Okay, so I'm working on getting C by itself. Ooh, there's 2 things outside. There's this plus 160, and there's this divide by 5. We're always going to do the multiplier divide part first, because that's furthest away. So here, whatever we do to one side, we do to both. So we're going to multiply by 5. Now, on the right side, that 5's whole job is just to cancel the fraction. Don't distribute it. So job 1 done. The fraction part's gone. Good. What's that? No? Okay. So I start looking again. I'm like, okay, next job. Plus 160's got to go away. So I get that out of there. Okay, the 5F and the 160, it's not like terms. I can't do 5 minus 160 there. Take negative 155. Doesn't work. And then I'm like, oh, I'm just multiplying by 9, so I divide by 9. So it is. It really isn't that bad if you just take a minute to get that set. 8. Okay. I can't count the number of times we've done these now, but we're going to add another one to it here. We're going to get these. We're going to get these. I'm solving for H, so I go to box my H term like, uh-oh. They both have H. And it's not like I can put those together because that's a number and that's a variable. Ooh. What will I ever do? Ooh, you're close. You're thinking in the right way. Okay, we got to factor it. We got to bust out the algebra 2 F word. What do they have in common? They both have an H. Okay, once I pull out what they have in common, I've got to go back. I got to say, okay, so in this first term, there's the H already. Ooh, I need the 2. All right. The second term, there's the H already. Ooh, I need the R. And if I'm not sure, I can go back and distribute. H times 2 is 2H, okay. H times R is RH. Sweet. Now there's only one H left. And that's what we have to be able to solve for it. So since I'm multiplying H, because that's what distributing is anyway, multiplying H times this quantity, this set of parentheses, the opposite of multiplying is to divide. So all that goes away. Okay. You can do this. And if some of you are still working on some stuff with the isolating variables worksheet, or maybe a few extras that I gave you on a quiz retake, use problems like this as examples as you're getting it. Okay, between this and the notes and things, we got lots of examples. We just got to keep plugging away here. All right, so now we'll get back to our applications. county fair charges $6 entrance fee and $2 per ride. Write an equation that describes the relation between rides R and the cost C in dollars for a single customer riding rides at the fair. So you're like, okay, let me think about this for a minute. My cost is going to equal my entrance plus any rides I do. Now, that's not my equation. That's just kind of my verbal model for this. You know, how is this going to set up? So then I go, okay, what do I know? Well, the cost they say is C, but that's really all I know about that. My entrance, I pay it once. Okay, so that's $6. So I can put 6, I can put the dollar sign with it. But on the rides, that little word right there, per, tells me there's going to be a variable involved. How much per ride times the number of rides I go. Nothing to solve on this one because they didn't tell me how many rides I rode. If they did, I can figure it out. But since they didn't, that's all I do. So again, it's just kind of plugging away at some of these things and seeing how some of that goes. Yes, sir?
Could you still put a variable after the fee or entrance fee? Like, could you still put like that? Or no?
You could attempt to. The only reason I'd say I wouldn't or that it isn't necessary is that it's talking about like a single customer. So it's not like we're saying we're trying to figure out the cost of 3 people going to the fair and each having 2 rides. Now, if they did, we absolutely could add it, and it wouldn't be wrong if you did that. Good question. All right, so another application. Rental car company charges $21 for each rental day and 35 cents per mile driven. The following model represents the complete cost of your car rental. What do the following variables represent? Okay, so what's the C stand for? Total cost, complete cost, any of those things are fine. What about D?
Per day.
Okay, per day, number of days, again, all good. And our M. Miles driven, couldn't say it any better. Okay, again, it's just understanding the verbal part of what the different variables stand for. Nicely done. So now, rewrite the previous model in terms of C and D. In other words, isolate or solve for M. So here's my equation. And my job is to start working on isolating my M term. So what do I need to do to get the 21D out of there? Subtract it. Nice. All right. One more step and we're there. Nice. Divide by 0.35. And so if I knew how many days I was out and I knew the total cost, I could tell you how many miles you'd driven. Oh, speaking of, if the total cost is 119, C, and you rented the car for 3 days, D, how many miles did you drive? Okay. So 119 minus 21 times 3 divided by 0.35. Now, everybody, including me, would go to a calculator on this. Here's how I do these. Whenever I start seeing fractions, I'll go ahead and I'll get what's in the numerator typed in. Once I have that, then divide by the 0.35, and I'll show you why that's important. Oops, slide that over. Because what if I try to put it all in at once? What if I just type in 119 minus 21 times 3 divided by 0.35? Oh, I drove negative 61 miles? What? No, it's just the calculator following order of operations. It did 21 times 3 and then divided and then subtracted that from 119. That's not what I want. So if you're going to go calculating, Do your numerator first, get an answer, then divide. It'll serve you much better, and it'll also get you a reasonable answer. And then finally, what we've been working on here yesterday and going to be today. Okay. Solve the following, write your answers in interval notation. I got to get all my x's together. I like keeping them positive because then I don't have to worry about flipping. And I just kind of keep plugging my way through. I'm like, okay, I got to add 12 because that minus 12 there doesn't do anything for me. Then I get here and I'm like, ooh. Divide by 3. Ooh, I'm getting a decimal. Is that okay? Yeah, it is. Bless you. So I punch in 8 divided by 3 into the old calculator here. And I get like 2.666666667. Okay. It's okay for you to like just round to the nearest hundredth or something. 2.67. Even if you did 2.7, it'd be okay. Now it says write my answer in interval notation. This is just a hint I would give. I'd make a quick sketch of this as a graph so you can visually see what's going on. And since I'm not telling you have to graph, if you just want to put 2.67, I won't yell and scream at you. But here's the problem. You're like, okay, it's a bracket. But the question is, which way does it go? Which way is my arrow, thank you, going to end up going on this one? Does this say x is less than 2.67 or x is greater than? If the arrow eats x, that's greater than. Okay, I got to be careful if I just follow the arrow. So if x is greater than goes to the right. And we already said that it's going to be a bracket. So now by visually seeing it, I can do my interval notation, which is always from the leftmost point of my graph to the right. The leftmost point of my graph is right here. And the rightmost point, well, there is really none because it goes and goes and goes forever to positive infinity. So I might make a suggestion for some of you. If arrow following is a big issue with you, you get confused otherwise, when you're doing these, just make sure all your x's end up on the left side then, because then you can arrow follow. And actually, we'll do that on letter B to make sure that we're okay with this. So let me get my distributing done first. And again, if you're looking for more of a comfort level, and you're not worried about the whole positive, negative thing, let's just get our x's on the left side and we'll play follow the arrow. So we got those guys together. Got to isolate this guy. But I have a different thing that can throw me a loop this time. So I get here and I'm like, okay, I'm multiplying x by negative 2. I got to divide. Okay, got it. Negative divided by negative is positive. Got it. Nice. Okay. If I multiply or divide both sides by a negative, not every time you see one, only if I do something to both sides like this, I've got to flip the arrow around. But at least I get to follow the arrow now, right? So I look at this and I go, okay, x is greater than 1/2. We just got done saying greater than means we're going to the right. So parenthesis, going to the right, and my interval notation follows. Leftmost point on the graph, in this case, is the number. If my arrow was going the other way, it'd be negative infinity. And I go off positive infinity to the right. So again, we're just testing out some patience here, taking our time with this, going through that way. So So then our last one on the review. Oh, one more application problem. For the trip to Germany, the German club is selling streusel. Makes sense. Customers can buy either apple streusel or Black Forest cherry streusel. Stephanie, time to start setting up equations. Stephanie sold 16 apple and 45 Black Forest cherry for a total of $716. So those first sentence or two just kind of gives me a little background. Once I start seeing numbers, that's where my equations are at. Johnny sold 91 apple and 15 Black Forest cherry for a total of $1181. Okay, set up a system. We did. Assign our variables. Now, I just chose A and B because I just took the first letter of everything. So A is my apple streusel, which I think I spelled wrong. Yeah, I did. Good job, me. And B represents the black cherry. And actually on both of these, it represents how much they cost. Because they told us the number of them. We're trying to figure out how much they cost. So I go back, run through my checklist on these. Can I add down and get rid of a variable right away? No. Life's too easy. Yeah.
Couldn't you multiply the bottom or the top by 3?
Nice. Okay. Right. When I get to the next part, I go, okay, let's see if I can multiply one of the equations. Well, I can't do 16 times something to get 91, but absolutely. Yes. Because 3 would get me to 45, but I need it to be negative 45, so it cancels. Negative 3. Nice, people. So, I'm going to leave my top equation alone. Rewrite it, because part of making sure things are going good is trying to keep our stuff neat. And then we're going to distribute, and the numbers are going to get a little bit large here. And now I see light at the end of the tunnel, because I multiply through and I go, hey, B's cancel. That's good. I wanted to lose a variable. And I go ahead and I just add down. And I'm not worried about seeing the negatives because they both have negatives. We know that negative times negative is positive. If I got a negative answer at the end, that'd be kind of weird. It's like we're giving people money to take the streusel. That doesn't sound like a good fundraiser technique to me. So we divide that out. And we find out we're charging $11 for the apple streusel. Hopefully that's kind of big, because otherwise those are kind of pricey. So then, I got one last part, because I need to know how much the black cherry ones are. So I go back. I can use either equation. It doesn't matter. So I'm going to start writing. I'm just going to use the top one. But I know what A is now. A is 11. Plus 45B, I don't know what that is yet, equals 716. And I just work this out. So I multiply those guys together. Again, the whole goal here, get that B by itself. So let's see. Oops, I'm putting my line in a little too quick, ain't I? I didn't need that line. 716 minus 1. Let's go here. And divide by 45. All right. Okay. So what you've got in front of you basically is the quiz tomorrow. change the story problems around a little, tweak numbers a little, but the types of problems and what you expected to do are going to be the same.